Thanks everyone for joining the second workshop on structural and compositional learning on 3D data. This is the second workshop happening after the first one in ICCV 2021. And the primary contact of this workshop, which is Kai-Chun Mo, unfortunately wasn't able to join, but he is on Zoom, so please don't hesitate to ask him a million questions. He will be able to answer all of them. So I'm very happy for this workshop because we have a great set of organizers. So here in Vancouver, Kai and Minhyuk are helping, and I am on site. And as I said, Kai-Chun will be on the Zoom. So our world consists of 3D data. It's a very complex and very beautiful world. So actually, this is a very nice city from my hometown in Thessaloniki. And as you can understand, the complexity of the 3D world is very big due to the diversity, to the fact that it is very unconstrained. And this gives rise to a lot of applications that rely on and try to capture 3D data. We have seen a lot of tasks ranging from autonomous driving to robotics. More recently, with the advances of NERF, we've also seen like 3D reconstruction of images in the wild. And if you ask me, what I find particularly interesting is also these medical imaging processing applications that could potentially revolutionize a lot of different domains in medicine and these type of things. So why compositional data are important? So our world is very complex, and as a result, objects cannot be seen in isolation. Instead, objects have relationships both at an object level as parts. What I was saying is that the world is compositional, which means that the parts should not be seen in isolation. On the contrary, objects should be seen as collection of parts, and 3D scenes should also be seen as collection of scenes. And as you can imagine, there is not only a single flat representation. We can consider relationships between parts as symmetry, proximity, etc. And for the case of scenes, the possibilities that we have in terms of the possible the possible relationships that can be captured are even more immense. Compositional learning has been extensively used for many tasks, for many 3D perception tasks, such as 3D reconstruction or manipulation, as well as a lot of robotics application. And the reason for this is that compositional representations can be particularly useful if we want to have a representation that better captures the semantic abstractions of objects and scenes. What currently might be more exciting about is compositional representations for generative tasks. So we have seen compositional representations being used for generative tasks of scenes, objects, and in a couple, I'm very confident that we will also very soon see representations for more higher level and more semantic concepts such as interactions, etc. Okay, so what are the topics that we will try to cover today in the workshop? So first of all, we will, I'm sorry for this, we will try to cover what are the best structural and compositional representation for different types of 3D data, such as depending on if you have point clouds or if you have voxel grids, etc. Of course, this is a very difficult question to answer, and I don't think that anybody can do this reliably. In addition to that, I think a very interesting question to ask is what is the best structure that we can use? The answer here is a bit dependent on the type of the underlying relationship between parts or objects that we want to capture. We will see throughout all the talks of today's workshop, people from different fields, and hopefully we will be able to understand how this type of data are used in applications such as robotics, a bit more pure perception, as well as some generative tasks. And we're very lucky because we have a great set of speakers today. We have 4 amazing keynote speakers, as well as 6 great spotlight speakers. So in this workshop, we'll encourage and always try to find people from that are both senior as well as less senior, because we hope the spotlight speakers will provide a bit more hands-on experience, share a lot from their struggles when they were trying to, solve their bug, etc. Whereas keynote speakers will offer us their vision, and we will be able to better understand where they see the field going. In addition to that, we have 11 presentations, paper presentations, and there will also be a poster session later on.